Okay, we're back to our favorite location for taking these videos.
Amsterdam.
Yes, Amsterdam, Nemo, and we're going to talk about mocks again.
Oh, that part is.
In any case, we will be talking about the mocks again. So we took two recordings so far. First, we talked about why mocks can be a problem. The second was about when mocks can be useful. And now we will talk about how to fix the problems with mocks. What are the workarounds? What is the solution for that?
So to go into that, maybe it would be first good to do a quick recap of what the problems were. Then we can go into how to work around and with these kind of things. So maybe let's do that.
To recap, we have 4 problems with mocks, as far as I'm aware. The first is that they make our tests not very readable because of excessive mocking and lots of pollution of the test code with the mocking setup. The second problem is that testing with mocks tend to test the implementation.
Yes.
That's how they are often used. So you're checking low-level calls, how the feature is implemented, instead of checking on the high level that the business requirement is implemented.
And then the third problem was that by having much mocking code, you really make it. You make your test in such a way that it's not only harder to change your code, but it's also harder to understand whether the code is correct, because your mocks do not have the same consistency guarantees that the actual code has, which of course is not guarantees, but that's what all your other tests are for. And then I think the final part, the fourth problem, was that you're losing a lot of the power that your tests have. As in, you no longer need to change your code to be testable. And testable code is, in general, code that's easier to understand. So changing your tests to work with bad code, which is what mocks enable, in my opinion, is worse than changing code to be easier to test.
Okay, so the third and fourth is that it's difficult to maintain mocked test code consistent with the reality because you need to manually tweak the request responses pair and anything that is related to the state.
Yeah.
And the fourth is that we lose the drive of the tests, requiring us to write more testable code.
Yes.
Okay, so what can be our solutions?
Well, I think we kind of went into this a little bit last time, that I use mocks more in the initial phase of a project, and as such, I almost consider a mock like a to-do comment. It's an indication that you don't have the right way of testing your application yet. I think that's a decent way to work with them, to use them as I'm parking this dependency right now, but I'll come back to it later, and then I'll properly address how to test the holistic functionality in my system.
And what would be those proper ways to address?
This is where paying as much attention to your test code as you do to your production code comes into play. So if you build test framework, essentially specific for your application, so that you can set up the state in such a way easily that you can test the actual use cases throughout your application. I think having that enablement usually drives you to have no need of mocks.
Do you have an example of such? What could be such enablement?
I think clearest example is like DSLs to set up application state.
Okay, so DSLs to set up application state. Yeah, I think that's quite a universal approach. I think what I would like to mention is first is to refactor the code. That's what I see often with abuse of the mocks. especially on the lower level tests, when you're unit testing and you see that there is a clearly defined function, some transformation, some validation, non-trivial, that you want to test, and you see the tests that do lots of unnecessary setup and unnecessary indirect checks, instead of just refactoring that thing, maybe exposing it for some people. Well, there are schools that says you should not expose your code for testing. I think, well, it's a little bit dangerous. Well, not dangerous. It's a little bit harmful thought sometimes. But if you follow this technique, okay, extract this into utility, and then it becomes a public function, public interface of your thing.
Yeah, because if you, just like what we were saying earlier with how mocks disable that, if you're dogmatic about never exposing something just for a test, you lose that power that the tests have, that they tell you that there's actually an abstraction there that is worth extracting, that makes sense in itself to test, and as such makes sense to be a unique abstraction in your production code.
Yeah, so very often, like those small things, small abstractions could be, by just refactoring very nicely, then tested in a very clear isolation, giving this, what is your reaction, giving this, what's your output, and then you don't have to involve all the machinery around it. Yes, another technique is to replace mock with a fake.
Yeah.
Obviously. Yeah. It's especially interesting when you're starting to climb a little bit higher on the testing pyramid, because there you don't want to focus that much on the details of interactions and don't want to test the implementation. Even, well, you want to test implementation even less than. So it's convenient then to replace mocks with the fakes. And those fakes, they can be either a very simplistic implementation, like in-memory repository, just keeping the stuff in memory, or even, okay, this will be a next one, a more realistic, more advanced mocks. But the main thing here is what they allow you. You don't have to worry about the consistency anymore, because the consistency is built into the fakes. At least the consistency that you expect, and you decrease the repeatability of the mocks.
Yeah, so I see what you're saying, that you decrease. You don't need to keep your mocks consistent with the code base, but you still need to keep the fake consistent with the system it's stubbing.
Yes, absolutely. That's the downside, but it's the same way as you have to do it with mocks, even just easier.
Yes.
And there is a next step. If you, depending on what you're stubbing or mocking, like if you take an example of a database, depending how you use it, can you just read write and you don't care much about it, but often you're starting to use it in a more advanced way. You have some queries, some consistency guarantees, some constraints, and so on. And then it's convenient to have actually a realistic database in isolation, or a realistic service. And that's what we see when we're replacing those fakes with dockerized Postgres, which is nowadays very easy to just spawn and reuse it in isolation for your tests. Or at bol.com, we had our own queuing system, and we would use this queuing system. The teams that were building it would provide a dockerized instance in memory that you can easily use for your tests. Same with PubSub of Google and Amazon with local stack. You have many of those primitives provided to you, and this way it's still probably not perfect, but you're much closer to the actual reality.
Yeah, and we're talking about functional low-level regression tests here. So we're the fact that a fake will never discover performance-based problems is just not an issue here.
Yes, absolutely. We are focusing here on the functional testing. Although sometimes with good fakes you will notice some misbehaviors, at least with the consistency and commits and so on. So not performance, but some infrastructural things you might notice already.
For these components, that's basically functional, right? Consistency, like unique key constraints, stuff like that. That's part of the functionality of these databases.
So that was about replacing mocks with fakes and even realistic implementations.
Let's walk through this. We have a fairly complex system that talks to a bunch of external microservices, and it has its own database, and it has a queuing system it talks to. So it has some transformations which we've now refactored away to their own components, so you can use just input-output testing there. Then it uses a fake for the database, or an in-memory replacement, for example, and it uses a fake for a microservice and a queuing system. It has a DSL to get these end-to-end states that are required easily set up. Is there something that we still need mocks for this database, for this service?
Okay, where we would have more temptation to use mocks still is for abnormal situations, to model the situation. Okay, yes, we have this database, but what if we have this exception, and maybe we want to test it even in a functional way because it's a part of our setup, but it can be complicated to...
That's basically internal chaos.
Oh yes, we might have certain situations when we say, okay, if this happens, we need to retry, or we need even to have some business event because it might be leveraged all the way to the business level, to the business logic. And in these cases, if we have our own fake, then the fake can become too complicated. If we have external something provided to us to fake, like Postgres database, it can be even not realistic to do this behavior. So we either have to fall back to mocks, or my alternative for that is still use spies. So I still have normal dependencies, normal components, but I wrap them for testing purposes with spies. And most of the time they will work like go through proxies. So we'll let things go through, but in certain exceptional situations I will say, you know what, next time when this call is made, throw this exception or return this thing instead of what you would normally return. And this allows me to really reasonably easy inject abnormal behavior.
Yeah, so then you don't need to keep it up to date. You don't need to worry about it when you're changing your code, but it does allow you to inject the abhorrent behavior. Yeah, good solution.
Okay, and I think that these are more or less our approaches to decrease the pain of mocks.
I look forward to work with this application and write new tests for them and add new functionality, because I'm going to be so confident and it's going to be so easy to change. It's like, oh, such a good day.
Yes, I would like also to say that not that mocks are inherently bad. They're a very useful technique. It's just we should not stop at just learning how to use the mocks, because there are lots of downsides, especially in the long run. And it's good to know the alternative techniques, their powers, and to use the proper tools for the proper situations. Because I can even give an example, actually, 6 technique. Sometimes if I want to deal with the consistency of the mocks, we would be extracting the mock setups into libraries. Right. And maybe we will even switch to dynamic mocks. The static mocks is when you're saying before the test runs, given this call, this will be your answer. Yeah. Given this call, this will be your answer. With dynamic, you can say when you will be receiving these calls, this is a callback that will evaluate what to do. And then you can do that dynamically depending on the other pieces of your test.
Then you're basically using the mocking framework to write a fake, right?
Yes, exactly. Then you are using the mocking framework to write the fake, which is not very convenient usually because the mocking frameworks are not designed for that. But that can be a good intermediate step. So when you're encountering a test which heavily relies on static mocks, you can start refactoring to that way before you start to get the proper fakes.
Right, sounds good. So thanks everyone for watching. It was fantastic to be in the sun and in person again. It's Go Vaccines, and I hope you're all staying safe as well. And please give us feedback on what we're saying, and if you like what we're saying, share it somewhere, and hope to see you next time.
Yes, now I have to check that I turned the camera on. I think it was on. Was it on? Yeah.